And what I'd like to talk to you today about is our flagship product, where we're talking about industrial IoT, and something that a lot of people don't talk about, not only when you're talking about constructing these devices, but also it's this idea of how do you enable the people who are creating these devices to actually do their jobs better. And so with Backtrace, we're improving the way software is built by improving the way that you debug. But in terms of IoT, it's really about making application errors actionable. And so what I'm going to do is walk through kind of a problem statement with you all. And apologies if you already know all of this stuff, but for everyone else, it helps you frame the problem a bit. And so here we have support, operations, and engineering. And the end user could be running a smart hub. It could be an Internet of Things device. And everything's fine and dandy. You got one device out there, everything is good. Except for the problem when it blows up. And when it blows up, we have this problem of how do you get telemetry, measurement information from that device back to support operations and engineering. With IoT, this is an especially hard problem as well, because you can't rely on constant internet connectivity. It can't just be time series information that's actually giving you visibility into what's going on. Oftentimes what happens is, you'll have to dig a bit deeper. You'll have to do something known as postmortem analysis to be able to truly understand the reason for the application actually, crashing or, giving you a critical error. And so in the case of a single instance, this is fine. Except, if you're going to make it big, you're going to have thousands of instances out there. And so you're going to have a cascading problem where more and more of these incidents happen, and you need to be able to facilitate the understanding of the issue at hand. And so not only is it an inefficient problem and a costly problem, it's a very complex problem. And the reason why it's a complex problem is because the way information travels back from the device to support and operations is through these very large, highly dimensional, very rich assets. Such as application dumps, logs, etc. The way that support and operations and engineering facilitates communication is through internal ticket tracking. It's not through kind of a system where they can easily share information and collaborate. And then engineering may end up actually having to go back into the device itself. And again, what they're doing is they're using kind of in-house built systems that they've cobbled together that they're really not fully supporting to be able to understand this information. Now, all of this is very complicated. You can think of this as millions of devices, et cetera. Now, the problem, though, is the process behind which you go through and debug. And so with critical errors, you have this idea of a notification of what happens. After the notification, the support and operation teams immediately have to go through some sort of remediation. Hey, my smart hub isn't working anymore. What do I do? Restart the device. Do something. Well, tell me what's going on. I got to figure out immediately how to remediate the situation. Then support says, hey, I can't deal with this. Let me triage and prioritize this information. So then they go over to engineering and they say, okay, this is the customer ticket. And then how do they transfer that information back and forth? And then engineering goes, well, I need more information. Can I get access to the device? This is fine when you're maybe dealing with a cloud system, but even with cloud systems, and more importantly with IoT systems, you can't rely on automatic connectivity, just the availability of information. You really need the ability to have robust capture mechanisms, be able to collaborate, and be able to do aggregate analysis across these devices. When I say aggregate analysis, I really do mean Internet of Things is about deploying millions and millions of devices out into the wild. It's not about deploying thousands of servers. It's really about getting full kind of permutations of all the different devices around your refrigerator to kind of the thermostat in your home. This includes sensor data, et cetera. And so I've said all this information, and kind of the point I want to drive home is that you've got proliferation of devices. It's really hard to get information out there, and you can't rely on kind of the existing systems that we've built for our server-based workloads just to be able to diagnose this information. And that's because not all data is created equally. If I had this device that was always connected to the internet, I could be generating time-based or time series information. I could see information over time. Except when you're dealing with incidents, it's very episodic. An application crashes. What I actually have is very rich information on what the application was doing at that time. More importantly, if I've got millions of devices and millions of devices crashing, I need to be able to do aggregate analysis across it. Of this crash, how many devices were experiencing this crash at this specific time? And so I need to take this very rich information, and I need to be able to do analysis across those episodes or those events. And so examples of this might be exceptions or application dumps. So Backtrace, and what I'm here to talk to you about, is this idea of a platform that is able to manage and help you automate the way your team handles application errors across platforms and across environments. So whether you're developing a custom device or using off-the-shelf components, you can use Backtrace as your data management layer for application errors. Customers use Backtrace to date to improve end user experience and device quality. And when I say device, I mean the full device, not just the hardware, but actually the software, to accelerate remediation and resolution of these incidents. So really going through that process of triage, prioritization, and fully accelerating not only getting a better end user experience, but also resolving the root cause, the root issue at hand. And then finally, to increase software quality. And kind of improving that development cycle helps you kind of reduce the number of errors that you have. How does Backtrace do this? So Backtrace does this by providing a platform that does cross-platform, cross-environment capture. Allows you to capture the complete context of the crash. So not only can you tell it such things as the state of the application, but you can also tell it the version of the application that was running at that time, which device, which hardware revision. You can add as many attributes as you want, and these custom attributes allow you to slice and dice your data as you so choose. And by being able to slice and dice that data, it helps you understand that information. Be able to do aggregate analysis across millions of these incidents that are happening, and to be able to get deep introspection into each of these incidents as well. It's really giving you a bird's eye view and letting you dig into the raw data. And then finally, it helps you automate it. It helps you automate it by integrating into your existing workflows. So if you're using a ticket management system, you can use Backtrace to automatically file tickets for you when your smart device is actually reporting an issue. If it's a unique issue, it does intelligent deduplication as well on that data. And then finally, it allows you to easily collaborate with this information. Because you have a single system of record where all of this information is captured, you can easily share URLs, you can share the context with the data that Backtrace has there. From a technical standpoint, just want to briefly go over this, kind of the Backtrace crash management platform, really being able to handle the application crashes that you guys see across these incidences can happen happens across environments, production, QA, or development. You can send this application information to the Backtrace database where it does intelligent deduplication, gives you full-featured query capabilities, and automated analysis. And the important thing is also that it makes this very easily to retrieve, makes it easy to retrieve this information. Provides modern interfaces where you can query and really kind of not have to deal with the painful process of being able to extract this information and understand it. So I'm talking to you about kind of IoT, and that's how I framed this conversation. But just for a little bit of context, Backtrace kind of applies to software running out in the wild everywhere. We have video games, multimedia, and desktop applications using us. We have CDN companies using us. Ad tech companies, people making device drivers for GPUs, and embedded devices, IoT and storage and network appliances as well. And so, Backtrace really is about creating this data management platform to help you automate and manage the error information coming from your applications. So what does this actually look like? I apologize. So I'm a one-man show tonight, so I'm going to try to shuffle around while I'm doing the demo here. Hopefully everyone can see this. Is that showing up? Okay, great. So it is. So this is an instance of Backtrace running out in the wild. And what you can see here is the Smart D device where I see some people. So the Smart D device where you have, over 261,000 errors have been reported. However, only 16,000 of them are unique. So immediately you can see kind of the intelligent deduplication. So imagine if 10,000 of your devices were all reporting the same crash or the same error. Backtrace will automatically do this deduplication so that you can actually reduce the amount of noise that you're looking at. You can see the last error report was submitted 2 minutes ago, and they've seen heightened activity actually since a couple weeks ago. And you can immediately see that trend information. What I'm going to jump into is our query builder And this is where we can see the power of aggregate analysis across all of this information. The first thing you'll notice is that over the last month, they've seen 268,000 errors. We see some suggested questions or queries, such as what are my unique crashes, how many different classes of bugs are affecting me, but you'll also see saved queries. So these are queries that this team has actually put into the Backtrace system that they can use over and over again, and they can easily share amongst their team. So I'm going to look at top crashes over the last day. And I'm going to show kind of here the edit menu for the query, where we're querying data over the last day. We're showing, and the filter here is we're only seeing crashes for a software version that equals this. I can immediately remove this, and I can see now I'm actually showing crashes over the last day that are grouped by fingerprint. This is kind of a key or a mechanism by which we group it. And then we're showing information about the set of data that we see here. So let's say, for example, I want to see the number of unique devices affected by, let's say, this particular crash group. So what I'm going to do is I'm going to type device ID, and I want to see the number of unique devices affected. So I can see here that even though I've had 1,500 errors, only 1,400 devices have been affected. And I can immediately retrieve that information. Kind of the end developer workflow is that they're submitting this data to Backtrace via kind of either their existing telemetry or using our agents. And they're immediately able to see this information in impact without having to fumble around with their own internal tooling. Finally, kind of having an end-to-end system that allows you to do this, we also are able to give access to the raw data that was captured here. And so what I'm viewing here is actually the raw information that was captured from the device, where you can see the call stack, you can see various information across all threads, you can see the attribute information that was also captured, and so device ID, version, device type, etc. And this is all completely customizable. And so that's the, the demo of Backtrace, and kind of the takeaway here is Backtrace is really the data management platform used by developers to make their error information much more actionable. Yeah.
Just curious, I would imagine that the first time setup might be onerous. So can you just walk us through, like, when you find a client who wants to use this, what the onboarding and training experience is like for those engineers?
Yeah, so we support a number of integration mechanisms, including some that are open source, and so and that are industry standard. And so typically, for the IoT devices that we've encountered, they're using an open source project to actually create this data, and then what we do is they can just use our APIs to submit the data into the Backtrace system. There. We also provide kind of first-class support for Linux, FreeBSD, Solaris. We provide our own mechanisms to be able to capture application crashes on end systems and then submit that data. To give you an idea on kind of timelines, it takes, it could be as easy as just installing a package on the system. If you're using kind of a generic operating system like Linux, let's say, to kind of on the order of, let's say, a day or two for you to integrate kind of, this open source project or this library.
How much behavior information do I get? For instance, I have a sales force in Asia. They should have been waking up and starting making phone calls, and I find, let's say, 40% of the devices are not even on. Do I see that? While I say the American friends are at workbench and hanging out, so if their devices are off, that's okay.
So we're not an always-on live instrumentation. So we're not constantly streaming data to the Backtrace system to give you behavioral information or to give you introspection into kind of continuous overtime runtime behavior. What we're doing is we're capturing data at a point in time. And so if you have existing, let's say, measurements of usage over time that are in the application, and you can capture that at the point in time and submit that to Backtrace. However, you're not constantly streaming that usage over time to Backtrace, as I said. So again, this is around episodic type of data, these events, these incidents, where you need to capture as much information as possible and then submit it to a system to be able to do aggregate analysis and deep introspection.
So I noticed in that UI where you issued the query, it was
exactly. And I'm wondering, how real time is this? Are you guys like pre-caching this data, or how does that work?
I mean, it would be great if you could answer the question yourself. Oh, okay. So we're not pre-caching the information. We're actually doing ad hoc real-time analysis. By the way, that's my co-founder, everyone. One of the main people responsible for the tech. But as he correctly points out, we're not pre-aggregating or computing any of this information. This is real-time ad hoc analytics on top of this information. So as it's streaming in, you're able to issue these queries and immediately get results back.
I guess I've never used a tool like this. Can you contrast this with, I don't know, both logging and monitoring systems that might throw names that are familiar to me would be, I don't know, Sumo Logic, Stackdriver.
Yeah. So.
Does this sit in the ecosystem?
So with logging information, what you're doing with logging is you're essentially you're trying to capture a state of the application using kind of very simplistic mechanism, the log statement. So a single like a line, let's say. This is really where this fits in is when you have very rich information assets. So like an application dump or something that like a application dumps or crash dumps, et cetera, where it's not fully structured, you need some pre-processing to be able to understand the information. And more importantly, what you want to do is be able to extract key points of metadata that are embedded within that or kind of belong alongside where you can embed the context and then do this analysis on top of it. So what we're not So what we're not doing is consuming logs and then giving you the ability to search across it. What we are doing is we provide the adapters today to be able to take in your crash dumps. And so we provide those things out of the box. If you need something custom and let's say you talk to us, then we can provide that to you and work with you there. What you do have to provide is this additional context. So like the version, the device ID, et cetera. However, it's very easy to do that via our APIs. Does that answer your question?
Yeah, but so it's not useful for monitoring. I can't use this to make sure I can sleep tonight.
No, you can make sure you can do this to sleep tonight because our folks use us to make sure that their crash rates of their application. No, so it's on the order, it's very fast. As we said, it's real time. So immediately when the incident happens, the information is sent up to Backtrace. However, what I meant to say there is that we're not, kind of a real-time instrumentation system where we're constantly streaming metrics. So where you're just sending us kind of this is how many queries per second that I just responded to, or this is how many active users I have at this moment in time, where every second you're sending it to us. It's only at the event, at the time of crash, at the event of incident, where you're sending this information, and then you want to be able to do analysis across it.
You're saying it's event triggered. That's the key thing, and then it's triggered right away.
Right?
Okay. Yeah. It's a major event, so it's an incident, so to speak. So it's not like every second. It's when an application crash happens, you then stream up a large amount of information to Backtrace, and then that happens automatically.
So Abel and Samuel will be around. We'll get into the panel then for more questions later. Thank you.